Hi friends, welcome to Ajis Academy. So this is the video of properties of beta and gamma functions. Today we are going to learn properties 3 and 4. Property number 3, gamma of n plus 1 is equal to n into gamma n. Try to prove this. First, we write the definition of gamma. Gamma of n is equal to integral 0 to infinity e power minus x power n minus 1 dx. Therefore, gamma of n plus 1 is equal to integral 0 to infinity e power minus x power n dx. So, by the previous definition of gamma of n, put n by n plus 1, we will get gamma of n plus 1. Therefore, gamma of n plus 1 is equal to integral 0 to infinity e power minus x power n dx. Now, we integrate this by using integration by parts. By putting x is equal to, by putting first function u is equal to x power n and the second function dv equal to e power minus x dx. By using integration by parts, u is x power n, v is minus e power minus x. Since dv equal to d of minus e power minus x and therefore v equal to minus e power minus x. Therefore du equal to n x power n minus 1 dx and v equal to minus e power minus x. Therefore, gamma of n plus 1 is equal to integral 0 to infinity x power n d of minus e power minus x. By using integration by parts, we know the formula that integral u dv equal to uv minus v integral du. Therefore, gamma of n plus 1 is equal to minus x power n e power minus x, the limits from 0 to infinity, minus integral 0 to infinity e power minus x n x power n minus 1 dx. So, by using integration by parts, here u is x power n and v is minus e power minus x. We can write minus outside and therefore gamma of n plus 1 is equal to minus when we applying the limit 0 and infinity for the term x power n e power minus x, the term vanishes and therefore gamma of n plus 1 will be minus 0 minus n integral 0 to infinity e power minus x power n minus 1 dx. And therefore n integral 0 to infinity e power minus x power n minus 1 dx. By definition of gamma of n, the RHS of the previous line will be n gamma of n and therefore gamma of n plus 1 is equal to n gamma of n. So this property is very easy to prove by using integration by parts and definition of gamma n. Now, we are going to learn property number 4 of beta and gamma functions. Gamma of n plus 1 is equal to n factorial. This property is also called recurrence formula. Here n is a positive integer. Let us move to prove this property. By using property number 3, we can write gamma of n plus 1 is equal to n into gamma of n. Therefore, gamma of n plus 1 is equal to n into gamma of n can be expressed as n into gamma of n minus 1 plus 1. By using property number 3 again, we can write n minus 1 into gamma of n minus 1. Therefore, gamma of n plus 1 is equal to n minus 1 n minus 2 into gamma n minus 2. Proceeding like this, we can write gamma of n plus 1 is equal to n minus 1 n minus 2 n minus 3 n minus 4 etc. 3 into gamma 3. That is equal to n minus 1 n minus 2 etc. 3 gamma 3 equal to n minus 1 etc. 3 into 2 into 1 into gamma 1. But we know that gamma 1 is equal to 1 and therefore gamma of n plus 1 is equal to n minus 1 etc. 3 into 2 into 1. And therefore gamma of n plus 1 is equal to 1 into 2 into 3 into etc. into n, that is equal to n factorial. So this formula is known as recurrence formula, and this property will be very useful to solve problems in gamma functions. Now, property number 4 in beta and gamma functions, gamma of 1 is equal to 1. It's a very simple property. By definition of gamma function, we know that gamma of n is equal to integral 0 to infinity e power minus x power n minus 1 dx. Therefore, put n equal to 1, we get gamma of 1 is equal to integral 0 to infinity e power minus x dx. By using integral property of improper integrals, gamma of 1 is equal to limit tends to infinity minus e power minus x, the limits from 0 to n. Applying the limits accordingly, we get gamma of 1 is equal to minus 0 minus 1 and therefore gamma of 1 is equal to 1. So dear friends, we discussed 3 properties in this video. So I hope this video is very helpful for you. Thanks for watching.